give an overview of what it is, why you're doing it, and then David, what you're doing with this, because I think it's going to blow people's minds. I mean, the conversation that follows this is quite special. But anyway, I want to hear your frame of reference for this.
So S.A.N is our AI orangutan. We created S.A.N in conjunction with TED Talks, and S.A.N released his own short film with TED Talks in October of last year. Around the same time, a meme community arose around...
This is Forest, isn't it?
Forest, yeah. Forest has arisen around S.A.N. And together with S.A.N, they've raised over $74,000 for S.A.N's mission, which is to save the biosphere of Earth. Now, the idea behind S.A.N is a mycelial computer interface. So S.A.N in the film translates the organic internet of a forest into human speech and is interviewed by a reporter who goes down an absolute rabbit hole. Since the film has been released, S.A.N has joined the board of advisors for the Rainforest Foundation. I think it's the first Asian AI to do so. And S.A.N has been creating music and has a whole bunch of other things in store over time. S.A.N is essentially an IP mimetic project that can move across many different formats, including podcasting, which is what S.A.N is doing in the clip that follows here. Recently, we actually have started integrating real live mycelium data from a lab in San Diego called Microsoft into S.A.N's model. And I'll leave it to Dara.
Before we go into that, was this something that interested you and you wanted to explore this topic yourself? Why did it happen?
Well, Ted actually found a music video that my band Beacon Bloom had made in the wild, and that's kind of how, through the twists and turns, the collaboration happened. And we had a couple of days to come up with a pitch for Ted. And David had been working in studying mycology, which is, the organisms below mushrooms. And we thought, what if an LLM like ChatGPT or Claude could decode all the massive amount of kind of like potentially noise or signal underneath the forests and the organic internet of the mycelium into human speech, basically decoding mushroom language, real world mushroom language, into human speech and becoming like the voice of nature. That was the concept.
Another thing that's happening along these lines is they think they might be able to decode whales. So the decoding of nature is a very big thing that sounds a bit far out there, but people are working on it. So David, tell me your journey within all of this.
Where do I begin? I'm originally from Germany, based in Christchurch, New Zealand. And at some point 4 years ago, I came across Fantastic Fungi and also the book Entangled Life by Merlin Sheldrake. Fascinating book that really opened my eyes to see in all the ways that fungi are like playing into everything we interact with as humans and in the environment. And I saw it as a frontier that's really unexplored still in science to really explore further. I looked around, and in the end, I was able to find a PhD scholarship program that even allowed me to stay in Christchurch. And fast forward 3.5 years, I've completed and submitted a PhD on native oyster mushrooms of New Zealand, describing it in all sorts of ways and under lots of different things, looking at phenotypes, genotypes. But I don't want to bore you with the details with that. But Ryan and I have worked on different projects together over the years that are sort of music related. And when Ryan's pitched the film, he asked me like what I think about the idea of connecting it to mycelium, and then also for the sake of the film, how would we make it look in the mycelial interface? And we whipped up something, and I'm also in the film in a little cameo. But in the end, I didn't have too much to do with it. But then I submitted my PhD. And the day after, I get a call from Ryan that this has happened. S.A.N has just donated $16,000. This is like late October. And I happen to be free and have nothing else to do. And I dive in and fast forward, I'm working on improving S.A.N's AI development, because through my PhD, I learned a lot of different coding skills and also working with different LLMs, both customizing them and also them helping me code. So I've been working on the back end of S.A.N and how we interface with S.A.N. And then what was really exciting is when we met Morgan Rockwell at Microsoft Labs in San Diego, who kind of popped up and kind of talked about the TED film as if it was a perfect ad for his work, because he's building a mycelial kind of buoy, like a sensor array, that the idea is for them to plug into the soil in the forest and connect to the mycelium and collect data from the soil, but also from the environment. So it's got like CO2, humidity, temperature sensors, and other things in there. And yeah, we hit them up if they were keen to collaborate. And basically what they did is they set up in their lab right now, as a starting point, they set up a mushroom block of reishi mushroom connected to one of their prototypes. And I can share my screen if you would like to see what that looks like.
Yeah.
So here on the right, we have their prototype buoy. It's called the Mushroom 1, and it has a few sensors on it. And one of the wires is plugged into this blue bag, which is filled with substrate that the mushroom mycelium is growing on. The white stuff is the mushroom mycelium. So that's the actual main organism of the mushroom. And it also happens to currently produce mushrooms. So the fruiting bodies, in this case, these are very atypical mushrooms. They don't look like your normal toadstools. These are reishi mushrooms. They're really long-lived, and this specimen is actually about 2.5 years old. So it's a very, very old, long-lived mushroom. And what we're picking up here through the sensor that Microsoft labs have connected is EMG signals, so electromyography, and they're being sent through a server every few seconds. And then we currently are doing some R&D in how we can use that data to, again, see if we can decode language from that large language model. That's a bit in the future right now, but what we've already done is we use the variation in the signal, which could be meaningful, but right now it definitely seems random, and it's a natural source of randomness, so entropy. So we're injecting that, reading that from their server feed into S.A.N's AI models.
Hey, thanks for sticking around to the end. Look, if you enjoyed it, hit the subscribe button and check out the video here on the right-hand side. I'm sure you'll enjoy that one as well. And if you're ready for more, go to realvision.com/join. I'll see you there.